So this short presentation is about automated testing of OpenAPI, described RESTful microservices, utilizing open source tools. So a little bit about me. I bring several years of experience working on a variety of software projects. I work with clients from the USA, UK, and EU. I worked across many diverse industries. For quite some time, I've been working with OSGI, and some of my work, I can mention this, was mentioned by the OSGI Alliance. I work with people who actively contribute to the OSGI further development, and you can see the website linked for more information, not to take your time. The objective of the presentation is to be able to automatically generate REST API test scripts, test data, then automatically test OpenAPI described RESTful microservices using open source tools. I emphasize open source tools because there are commercial tools available. At least one I found when I was looking for possible solutions to a problem that I've had. But the licensing of these tools was a little bit prohibitive. The license was a minimum 8,000 euros. So I mentioned this about tooling available, so that regardless of your budget, you can utilize and integrate, for example, with CI/CD pipelines, the automated testing of REST APIs. For this short presentation, I prepared an application, an example application, and obviously, if we mention automated testing of REST API, we have to mention some of the technologies that the application is using, and the most basic and necessary things are obviously REST. We also talk about generating tests based on OpenAPI Swagger specification. So the familiarity with OpenAPI Swagger specification is required. If you do not know anything about OpenAPI Swagger, then this is just a simple way of describing your REST APIs. The REST APIs can be written in any language, and from that you can generate the specification, which you can further use for example, automating generation of documentation, for generating actual code, or you can start with the OpenAPI specification itself, and based on that, you can also generate clients, servers, documentation, and as you will see in this short presentation, also scripts which are used to test the REST API. So for the OpenAPI Swagger specification itself, I'll provide the links at the end of the presentation. We will also talk about part of the specification which allows to define example data at parameter level, at request body level. And having this example data, you can then generate both the tests and have the test data, which the tests utilize in order to automatically run. For these enhancements that I implemented, I will go into details a little further. We will also utilize so-called OpenAPI extensions, which basically allow to extend the specification beyond its original definition to allow, for example, as you will see, the grouping of request operations, ordering of them, also hiding some operations, and many other things which in order to actually generate tests which are of any use, not the most trivial ones, this is necessary. So obviously, the automated testing itself, you've heard about this. There are many different types of tests. Going from the lowest level, obviously unit tests, you use them in your software, integration tests to verify if all the layers of your application are communicating properly. And obviously the best way to verify that your application is working and everything works as it should is to go through the REST API, or if you use GraphQL API, that the application exposes for the clients to communicate. For the automated testing of the REST API, we'll be using K6, which is the only tool out of the many that I evaluated, which supports all of the requirements that I've had for this deployment, and also gives a lot of room for further enhancements. So one of the biggest, strongest value propositions of K6 is that you can generate user flow tests, which allow you to test the actual navigation in your application. And this is as it's quoted from the documentation, K6 documentation itself. This is the point that distinguishes K6 from most of the currently available load testing tools. Meaning utilizing K6, you can test realistic user flows and not just rely on hammering a set of endpoints, which the most trivial tests can do, but it doesn't really test the actual behavior of users in your application. So the example application that I will show you, some of the things that I talk about, also utilizes other technologies with which you do not have to be familiar, because as you know, for REST API you can use any language which allows you to develop JAX-RS REST endpoints. But these are the tools if you are interested, and I'll be sharing the code for everything that I mentioned today. Is OSGI, JAX-RS Whiteboard, EMF, MongoDB, Keycloak, because we also need authentication, and this will provide us with OAuth authentication, and Jenkins. As you can see in this sample application, we basically describe a set of 4 REST API methods. And even if we had no OpenAPI metadata, you would still be able to generate an OpenAPI spec based on this code. It will just not be so detailed, and it will not allow you to further process with to generate documentation and scripts and other tools as the OpenAPI extensions and the OpenAPI annotations allow you to do. So the basic idea is that as you develop your REST API, you add methods, you modify existing methods, you add new REST endpoints, and there are usually dependencies between the REST API methods. So the basic version of the tools that I've evaluated, and even the K6 generator, OpenAPI generator, does generate a very simple script based on the OpenAPI specification. However, the test itself is not really possible to use it, to run it. It's just a skeleton. So with these additional annotations and the extensions that I've implemented, you are able to actually generate tests which are ready to run. There are not skeletons anymore. You can use them out of the box. So this way, as soon as you are ready to test your new endpoint modifications, you can go ahead and generate the specification, regenerate the specification itself, And based on that specification, you can go ahead, regenerate the test script. The specification itself also it's important to emphasize that the ordering of the methods is not guaranteed, and as you know, since we want to be able to test the actual flow, the actual behavior of the user in the application. It's important to enhance the specification with additional metadata, which allows us to actually then generate the script which knows exactly which method should come first, which method should come after that, and also be able to extract these examples so that we can use the test data right away in the test scripts. And this way, when you go up to the CI/CD pipeline, you can automate the entire flow with this tooling. Which allows you to basically simply commit the code of your new or updated REST API endpoint and have the build server take it from there. So these additional annotations are simply output at operation level, at response level, and in a moment you will see how these annotations are used to actually generate the script. So now we have the updated specification, and we will generate the scripts. So we use the OpenAPI tools generator, which contains some additional enhancements implemented for the K6 generator. And you utilize message templates to drive the data that is fed from the Java code in the generator. So the templates themselves you can customize as you'd like. And here, out of the generic template that comes with the K6 generator, you can, for example, define some additional settings like options, how many virtual users you would like to have for the script to run, the duration of the test itself, the thresholds. For example, let's say you have SLA metrics and you want to verify if a certain percentage of requests complete within a given time. Then all this is supported by K6, by this tool. And with this, you can go ahead and measure, actually gather metrics, how your application behaves and whether it is ready for production. So these additional enhancements that I make to the template itself allows you to utilize Keycloak or any OAuth compatible server to automatically log in before executing the request. So obviously you need to pass the bearer token, the additional headers, and there you have the requests themselves. Well, we have the script generated, so let's look at the script itself. This script is generated based on this message template and the OpenAPI specification, and it's a script that's ready to run. As you can see, all the imports, all the settings, and also all the data that is needed to run the test is here. And if we fire off this test, then you will see that the test is ready to run out of the box. So out of the run of the test, you can see at the very end all the different metrics which you can then feed and process further because you can output them in a variety of formats. So here we have this basic flow which basically knows which methods must come first and the ordering guarantees that you first create, for example, the actual entity in your database. Then you can query for that entity by its ID. Then you can list, for example, the entities and delete at the very end. If the ordering was not guaranteed, then obviously the test would fail. It would also not be able to work on, for example, empty database. So this is a very basic demonstration, and let me just go further with the presentation. So as I mentioned, the problems with the existing tools is the no guarantee of ordering, but obviously the requests must be ordered for anything but the most trivial tests. There's no example data, and the generated test is only a skeleton. There's the quite significant problem, and something that usually with such solutions in time causes that the tests are completely different from how the API evolved, and someone must continuously keep the tests up to date, because otherwise there is no point of having any testing if the tests are not up to date. So the problem of code drift and keeping the REST API and REST API tests in sync. Also, the ability to automate this and have this running as part of the CI/CD pipeline. This is something that is obviously a huge bonus, but this allows you to do exactly that. So I shortly presented you the solution in action. So the OpenAPI tools K6 generator enhancements that were implemented to support this is, as you were quickly demoed, the parameter example data extraction. So this allows you to extract examples for specific parameters like query params, path params. And then the request body example data extraction, where you have, for example, post methods, and you want to provide the sample data for that post method. You can now extract it from the OpenAPI specification that's generated and put it into the script automatically. The request grouping and ordering, as mentioned previously, is something very important and allows you to generate the actual flow tests. And also the response visibility itself. Let me show you quickly. This is something that is important because if your OpenAPI spec, for example, defines several different responses that can be received for a given request, then obviously the script that's generated should only test against only one of these responses, the one that you want to test against. So this additional enhancement allows you to hide a certain response, so that the script generated only tests against, for example, status 200, and this is completely up to you which one you want to test against. The responses for 200 are generated by default by the K6 generator, and obviously you do not test it against the 400 responses, 400, 500 codes. This is something that just happens, unfortunately, sometimes. So this is the response visibility enhancement. And all these are possible through the custom OpenAPI extensions. Some of these things are already part of the OpenAPI tools project that were merged a couple of months ago, and the latest release will contain them. Some of the other enhancements that I added just recently will be merged further down and hopefully very soon. So the OpenAPI extensions again allow you to order operations. So you define which operations must be executed. So data is created first, only then queried for, then deleted. The operation response visibility, which I just mentioned. So in detail, this is whether the given response should be hidden. So not all 200 code operation responses are checked against in the generated script. The extensions, which will be, you will see the exact usage in the documentation. So those are two extensions: the K6 OpenAPI operation grouping for grouping and ordering, and the OpenAPI operation response for operation response visibility. And with time, hopefully, some of you will add more things which allow to further automate this work. So with this, you can generate the REST API test scripts automatically based on automatically generated OpenAPI specs. So you focus only on the code development, and then everything else is done for you from that point on. And this way you can run the REST API tests continuously as part of the CI/CD pipeline. Some of the tools that I mentioned, which were not up to the task, I will mention them by name. But the basic problem is that none of the tools evaluated met the requirements. They were either not open source or had very expensive license. They were incompatible with OAuth 3, the latest OpenAPI spec. They did not support the OAuth 2.0 authentication, do not allow the automated generation of tests based on OpenAPI spec, or just simply do not support the variety of test types that you need in order to fully cover your REST API. So not only smoke tests, but also load tests, scenario tests, so-called flow tests. And also the ability to measure service level agreement, service level objective metrics. So some of these tools, obviously, curl, Rester, similar, Dread, Swagger test templates, OAuth, and SOAP UI does have some of these capabilities, or most of these capabilities, in their commercial product, which I mentioned at the beginning. The license is about €8,000 minimum. So let's just quickly mention the flow that I wanted to upgrade. So the flow, until now, you basically edited the REST API code. You either added or updated the REST API method params, method example. You then had to manually update REST API test scripts, for example, curl calls or REST test definitions, or the definitions in one of the other frameworks, but you had to manually do that step. Then manually update the example data payloads used for those REST API calls. Then manually or half automatically run the REST API tests against local or development environment. Then you could make the commit. And then again, obviously you want to test this in your staging environment. So then you had to, again, manually or half automatically run those REST API tests. But again, the problems that I discussed a couple of minutes ago reappear over and over. So the flow with these new toys basically allows you to edit the REST API code just like you do, but then everything else is done for you automatically. So you can automatically regenerate the OpenAPI spec, the REST API test scripts, the example data payloads used for those REST API calls, and then you can automatically also run those REST API tests against local development environment. Then the quicker you can do it, then the quicker you can make the commit. And once you make the commit, if you had the pipeline configured with these new toys, then again, everything else is done for you. So those tests can be run as part of the CI/CD pipeline. And let me just quickly show you how this is done on an example project, on a commercial project that I deployed for a client. So basically, the the prerequisites for having automated REST API tests is you need to have automated deployment. The application, my application must be built. The container, for example, Docker container, must be deployed to whatever Kubernetes or Docker Swarm or whatever environment you use. You don't have to use Docker, obviously, but you need some way of automatically deploying the application. So then you can run the smoke tests, and then the scenario tests. The results you can visualize. They are visible in the logs themselves, or you can visualize them in the K6 cloud or via additional K6 plugins. So basically, this allows you to output the results to a variety of tools like K6 Cloud. If the log output is not enough for you, and this is very detailed, but if you want to process this further, then you can use K6 Cloud. There are also Jenkins plugins which you can utilize. So as I mentioned, I will share this via the OpenAPI Tools project. Some of the stuff was already shared and merged and will be released soon. The other things that I enhance further will be also released. The application itself that I showed you today will be made available as well, so that you can see all these different things in action. And for more information, you will also be able to look into the slides for more links, which you can further read up or maybe help with developing this further. So thank you very much, and I can take your questions now. So the first question that came in is, did the source code was published for the example? The source code is published, yes. The GitLab repository link, I published a link to the page for the session, so you can just go to the session page, and there you will find the link to the project. It's on GitLab. So I also provided this information to Cedric and David. So the second question is, what are the limits? Are there some REST APIs which are especially hard to test with OSS tools, in your opinion? That depends on the amount of interdependencies and what kind of data you need, and also obviously this is something that can be further enhanced. So if something is missing, you need to further make it process more complex cases, then you are free to enhance it further. But for some of the problems, for most of the problems that I came across, this is a solution that allows to completely automate this. And also the problem of requiring the additional knowledge, tech stack knowledge, goes away, because the person who writes the code for the REST API, they don't have to know this additional technology stack, and that's that. So the third question, what about API which doesn't have the OpenAPI spec? Is there a way to bridge the gap? Well, all this is driven by the OpenAPI spec, so you do need to have the OpenAPI spec, but it's really easy, because you can generate the spec via Gradle plugins, via Maven plugins, whatever you use for your build, and probably as well. I've used Maven and Gradle for this. There are also some plugin frameworks which you can plug into your existing application, and this will generate the OpenAPI spec on demand. But you you do need the OpenAPI spec, because this is driven by the spec. The OpenAPI generator project on which this depends needs the spec in order to process this further. So if there are no other questions, then again, I invite you to visit the page for this session, and there you have the, there's another question. Is K6 related to one of the generators listed at OpenAPI Generator Tech, where the K6 contributed the original K6 generator, which I enhanced. So that's that. So thank you very much. Please see the page for the session, and there you will find the slides and the project. Thank you very much.